Welcome back to Engineers Club. Today we are going to learn about breadth first search algorithm. So what is breadth first search algorithm? BFS is an algorithm for traversing or searching tree or graph data structure. It starts at the tree root, as they say. It starts at the tree root or some arbitrary node of a graph, sometimes referred to as the search key. Explores the neighbor nodes first before moving to the next level neighbors. So this is the definition given by Wikipedia. I'll be walking you through what is a BFS and why we use it. What are the uses of using a BFS, right? So as I say, BFS you are exploring the neighbor nodes first before moving to the next level neighbors. So the word level here is important. Let me take a tree for example, which we are going to use it for further demonstration of this algorithm as well. Let's take a graph, because if you understand it for a graph, you'll be understanding it easily for a tree as well. So the algorithm is same for both the data structures. So let me take this 6 here and let me connect it to a 7, which are connected like this, and then an 8, which are connected like this. So I've just drawn a random graph. So let me connect this to also. It will look nice and clean. So as you can see here, we can traverse at any vertex, visit any vertex, explore it completely, and then move to the next vertex, right? So as I've said, this following line, visiting and exploring, these are the two statuses for a vertex of a tree or a graph. So what do you mean by visited and what do you mean by exploring a vertex? Visiting and exploring, and also we'll get to know the differences between visiting and exploring them. Okay, so yeah, pardon me if I am a bit slow in writing this. Okay, I hope you'll understand. So visiting, what is visiting? Suppose you are um, suppose you are going to the first vertex. That means you are visiting vertex 1, and the neighbors of 1 are 2 and 3. I hope you understand neighbors. Neighbors means the directly connected adjacent nodes. So what are the adjacent vertices or nodes of 1? They are 2 and 3. So the neighbors of 1 are 2 and 3. So once you visit 2 and 3, that means you have completely explored 1. Suppose then you go to 2. So what are the connected vertices of 2? They are 1, 4 and 5. You have visited 1 already. You are yet to visit 4. Suppose you have visited 4 and now you have visited 5. So that means you have explored vertex 2 completely. So I hope you understood that the difference between exploring and visiting is that touching the vertex for the first time, for one time, just touching the vertex, just going to that, landing up there, means visiting that place, visiting that vertex. Whereas exploring means to visit all the connected neighbors of that vertex, right? To visit all the connected neighbors of that vertex. And to visit all the connected neighbors of that vertex, you have to visit all the adjacent vertices. That means we can even derive it like this, that a visited, like an explored vertex is always visited. But the reverse is not true, because a visited vertex may or may not be explored completely. This became an infinity sign. I didn't want it to become an infinity sign though. Right. So it's not necessary that you have to explore all the vertices. You have to visit all the vertices, and after visiting all the vertices you have to explore them. According to the BFS algorithm, it instructs us to visit a vertex, explore all the explore it completely, rather visit all the neighboring vertices completely, then go to the next vertex, then again explore it. That means first we visit, then we explore, again we visit, again we explore. We keep on going like that. So that's the BFS algorithm. So these are the two basic status, you should call it status of a vertex in a BFS algorithm. Next I'll tell you why we use queue in a BFS algorithm. In a BFS algorithm we be using a queue data structure. So a queue is a data structure that follows FIFO mechanism. FIFO is first in first out mechanism. Suppose you have a data structure like that, an array say, and you are inserting from this end, like you're inserting from this end, and then the second element inserts here, third element is inserted here, fourth element is inserted here, and now you command the queue to delete the first delete element. So it will not delete any other element, but it will delete the first element. Once the first element is deleted, it will delete the second element and then the third element. So this is very similar to booking tickets for the movie in a, like a queue, the queue you go for while booking movie shows, like it's like that. So the one who goes first comes out first. It's like a first in first out, first come first serve type of data structure. So we will be using a queue for BFS. So that's all for this video. I'll be giving a brief walkthrough through the algorithm of BFS, and I hope you understood the differences between visited and explored, which are the two status for any vertex while applying the BFS algorithm.